Hey, what's up? This is Václav. In this video, I am giving away the full energy management for your home. I'm not gonna come to your home and configure it for you, but I will show you how it's done and how it works. What it does is it protects the home from power outages. It optimizes the house battery charge and use based on the solar forecast. And it automates smart charging of the electric car from the solar power. In March, I made a video showing how it works. If you didn't see it, here is the link. So today I will show you how it's done in full detail. As a bonus, I'm also gonna show you how I organize the automations in my setup. Now, one notice, currently I do not manage energy import and export based on the spot price, because I don't have one yet, so that may be coming next. Now, I know you will have two questions, so let me address them before we start. First, if I can share my automations. Well, check in the descriptions, I did share them, but the configuration is tweaked to my needs, so if you just copy them from there, it won't work unless you have exactly the same setup as I do. If it was as simple as posting the config, I wouldn't bother making this video. But I know I'll get the question anyway, so the link is down there. But the point is this video, and most of my videos anyhow, is to explain what I do, why and how I do it, to inspire you to do something hopefully even better if you want to. Relate to that second question, why I bother doing it and why I make it so complicated. Well, because I can. This is my home. There are some pieces that are rather simple, but I like perfection, so I usually take it to the next level. I leave it for you to decide how far you want to go, perhaps even further than I do. If you want to learn, that is. Also, you will need some understanding of automations and templates. If you don't, well, you can just relax, watch and let me know if you like my setup. Or I made an automation masterclass, so you can start there. So with this out of the way, let's get started. I have 5 automations for the energy management, from simple to kind of, well, you will see. So, are you ready to dig in the automations? Well, hold your horses. There's one more thing I'd like to show you, and I'm sure you will like it. And the thing is, how do I organize my automations? I don't use the packages anymore. I organize everything from the user interface through the visual editor. So everything is at the end stored in a single file. So how do I find the automations? How do I manage them? Let me show you. I'll go to the automations. And as you can see, the first thing I do is I use a limited number of keywords to name my automations. So you could see all of them that are dealing with alerts or checking things or controlling some devices or the lights or notifications, reacting on timers. They use a specific keyword that makes it easier for me to find them because they're gonna be sorted next to each other, so it's easy to find them. The other thing I do is I use those emoticons that are making it easy for me to spot them. So all of them that have something to do with the water, for example, they have this little emoticon with the water droplets. And I also use an icon in here that makes it easier to find it. The other thing is I use areas. So if I would go to the workshop in here, these are all the automations that are related to workshop. And in the workshop, I have 3 things essentially. There is the battery and the photovoltaic control panel. So all the energy management is going to happen there. Then there is the 3D printer, so I could do that, and then there is a light. So these are the 3 things happening in the workshop, so I can find them this way. The other thing I can find them is, I can go to the devices, and if I will go to GoodWe, then here again, these are all the automations related to the GoodWe inverter, so I can find them from there. If I would look at the car, for example, so this is the Skoda automation. So there are all the automations related to my electric car. So it's actually not that difficult. So what I'm gonna do today is I'm gonna go to the automations. I'm gonna type EMS, and it's gonna find all the automations related to energy management systems, which are the 5 we're gonna be talking today. Before we go to the automations, let me show you a couple of helpers that I have created to set up parameters for the automations to use. I can find them on this energy management dashboard. Whilst we're there, on the right side there is this pretty nice chart that is showing the current energy flows. It's showing you that currently the solar panels are producing about 2.5 kilowatts. 1.2 is used to charge the car, and about 1 kilowatt is currently used to charge the batteries, but it's jumping around, sometimes exporting, sometimes importing. The reason being, if you look at the current energy production, in the morning it was pretty clear skies, pretty stable, but since around 8 o'clock in the morning there's lots of clouds coming, so it's jumping all around like crazy, and you could see the energy management on the bottom is reacting on that and keeping charging of the car within the limits. So coming back to those parameters, the first one is the master switch, which I use in all the automations to disable them or turn them on. Then there is the threshold that helps me to decide whether the next day it's gonna be good for solar production or not. It's using this solar forecast number, so currently it's on 28 kilowatt hours to be produced next day, and currently the threshold is on 15, so next day is gonna be evaluated as a good day, and therefore it will take the value for good day, so this is 85%, that is gonna allow as a depth for discharge of the battery, so allow more of the battery to be used over the night because there's going to be sunny tomorrow. Same thing for the car, it's going to be sunny tomorrow, so it's going to charge the car to a lower value overnight to 75%, because I can expect that before we leave the home the car will top up from the sun. And it works quite well because the car was on a 75% in the morning, and currently it's on 81%. On the next panel, probably the only interesting one is the scheduled power outage. When I toggle it, it will basically start charging the battery, preparing for a scheduled power outage, making sure that there is enough power in the battery. The remaining ones, they are controlled by those parameters, by the automations. They are usually part of the integration of the inverter. There are different modes. From those, I use the general mode, backup mode, and eco charge mode. Then there are some additional parameters in the car dashboard, but again, those are typically controlled by the automations, but I can also set them manually. This is the mode. There is a fast, scheduled, available, and off, and I'll explain that later when we go into the automation. There's also the minimal charge overnight for the scheduled mode. So it's set by the automation to 75%. We already covered that. There is a switch to turn on and off the charging, and then there's a charging current that again is set by the automation. By the way, there is the panel on the left side which is showing you that the car was consuming on the last trip 16.6 kilowatt hours per 100 kilometers, and currently it's on 81%. So today I charged about 5 kilowatt hours, meaning that I charged worth of about 30 kilometers since the morning from the sun. On the bottom there are all the parameters about the current charging, so it's plugged in. If I continue, it will be charged in 6 hours, but we're gonna leave before that. So the current charging power is reduced to 8 amperes, which is 1.9 kilowatts. So it might not be the best day for the solar plant, but if I come back in the afternoon and if I look at the whole morning, look at that. So this is when the car was charging. My wife left at around 10 o'clock in the morning. When she left, the car was at 86%. She now parked close to the office and it's still on 80%. From then on, all the solar power was going to the house battery, so you could see the capacity increasing. It had 17% in the morning, and at around 1 o'clock it was fully charged basically, and from then on the house was pretty much exporting the energy and covering own production for the whole afternoon. And the house is fully charged, so not bad after all. So now that you've seen it in action, and got organized, we can finally begin. Let's start from a rather simple one. What does it do? It controls the battery used for the house backup. In case I get a severe weather warning about a strong wind or thunder, or when I get a warning about a scheduled power outage from my distribution company, the house prepares for it and makes sure the battery is fully charged. Also, if I charge the electric vehicle at night, it prevents it from charging from the battery, since the battery capacity is much smaller than the car and the battery, so it won't make much difference for the car, and it just consumes the house battery and cycles it unnecessarily for no reason. Is this a good logic? I don't know, but this is what I have for now. So let's see. Okay, so let's start with the first one, and that's the one in the middle, which is handling the battery charging mode. I'm gonna open it. This automation is handling car and the battery, and it's triggered by three things. One is the severe weather forecast, the meteo alarm, which is a binary sensor. I have the same thing with the scheduled power outage, which is a input boolean I have on my dashboard. If I get a warning from the distribution company that they are planning some works and there's gonna be power outage, this is going to trigger the automation as well. And then there's the sensor or switch that the Citigo is charging. That one comes from the Skoda Connect integration. And then I'd like to adjust the way the house battery is charging or discharging. Then I have a condition for all of those energy management. I have a master switch energy management, which is input boolean. Then I can turn the energy management on and off centrally using one switch. I have that through all of my automations. Then all what it does is there is an action set option for the inverter operation mode. This is the entity provided by the inverter integration, and it's changing it to a mode. And the mode is a variable that I set using a template in the previous step. So let's look at that. So this template is going to set the mode to one of the three values, either echo charge, or backup, or general. So first, echo charge. It's going to set it to echo charge if there is a risk of a high wind or thunderstorm, or the input boolean scheduled power outage is on. So if I schedule power outage, or if the severe weather forecast is forecasting high wind or thunderstorm. Where did I get this one? Well, this is a variable I have defined up here on top, and what it does is it is looking at the state of the binary sensor meteo alarm. If it's on, so it means there is an active warning about severe weather, and the severe weather type is either 1 or 3. 1 is high wind and 3 is thunderstorm. You can find it through the API documentation for the particular meteo alarm I'm using. Right? Now it's using one more variable here, severe weather, which is essentially the attribute of the binary sensor meteo alarm. The attribute is called awareness type, but I'm pre-processing it up here, because what I do is I'm first checking whether it's defined, and if it's defined, then I'm taking the first part before the semicolon, which is a number. Let me show you in the developers tools how it looks like. So let's paste it here and let's slice it to different parts. So it's using this state attribute binary sensor meteo alarm awareness type. So I'm gonna just show it in here. So this one has a value 6 semicolon low temperature. So what I'm doing is I'm splitting it by semicolon, which is going to create a list of two values. First is going to be 6 and the second one low temperature. And from there, I'm going to take the first value, which is the number 6. So in this case, number 6 is low temperature, and this is not going to trigger charging the battery because I'm only limiting it to high wind or thunderstorm. I also check whether the attribute exists, because if it didn't exist, it will say undefined error, the attribute doesn't exist, and the split doesn't work. So in this case, to show you the result of this variable, so it's severe weather, and this is number 6, but if I would delete the attribute because this one doesn't exist, it's saying, is it defined? No, it's not defined, and therefore it will return empty string. Let's go back to the automation. So this was the echo charge mode. So we set it to echo charge if there is a risk of high wind or thunderstorm, or if I set the scheduled power outage to on. Then there is the backup, which is used when the CityGo is charging and the car is at home and it's either in fast or scheduled mode. I will explain those modes when I explain the last automation, so I will skip it in here and I'll get back after I explain that. In all the other cases, I'd like to set it to a general mode. Now, if the inverter is set to the echo charge mode, then I'm setting the echo charge parameters. So what it's saying is, if the mode is echo charge, I'm setting the number entity echo mode power to 75%. Then I'm setting the echo mode state of charge to 100%. And I'm also creating a persistent notification that I have just turned on the charging on the battery to 100%. So I'm notified and I know that the battery is currently charging fully because there is a risk of power outage. Then there is another one related to the backup. The battery backs up the whole house. But when there is a power outage, I'd like to turn off some appliances with a high consumption that are not really critical to run all the time. I've configured them in the group, so I can easily manage that group to add another one if I want to. But essentially, it's the swimming pool, circulation pump, and the electric stove that really takes quite a lot of power. If I had a smart fridge, I would probably increase its temperature, but mine is stupid, so this is one of the things I want to keep running. The dishwasher and washing machine, the same thing, they take quite a bit of energy, but it's usually quite short. And I don't want to stop the programs if they're running. Again, if they were smart and they had a program scheduled, I could delay them, but they're not, so I leave them on. So let's see. Okay, so the automation is called handle power outage, and it's actually very simple. It has 2 triggers. Both are triggered by changing of the entity grid mode code, which is an entity created by the GUI integration. And when the entity changes from 1 to 2, it'll create trigger with ID power outage. And when it changes back to 1, it's gonna create a trigger with ID power restored. Then there's this general condition whether the energy management is disabled or not. And then there is 2 actions, one for each trigger. And if it's triggered by power outage, I'll turn off the group that is called turn off during power outage. And this group currently contains the stove switch. So this is a group. And then I'm going to also change the mode of the swimming pool pump to position off. I could have included that in this group in here, but in this case, the swimming pool pump is actually controlled by an automation which has 3 modes. One is on, one is off, and one is automatic. So in this case, it'll switch it to position off, which means that the swimming pool pump is going to be turned off. And then finally, I'm going to create persistent notifications saying that I have turned off those 2 appliances because there is a power outage. In case the power is restored, then I'm going to do something similar, but I'm going to turn on this group. Then I'm going to set the swimming pool back to auto. And then I'm going to create another persistent notification saying that those 2 appliances are turned on again because the power is restored. So let me show you in YAML, which makes it probably even easier. So this is it. If it's power outage, it's gonna turn off this group. It's going to set this option to off, and it's going to create persistent notification. And if it's power restored, then it's going to turn on this group. It's going to set this option to auto, and it's going to create another notification. So this one is rather simple. Then next one. Then one more battery related. The inverter is usually in a general mode, and what the general mode does is when there is sun, it will primarily use it to cover the house consumption. If there is more energy available, it will use it to charge the battery, and when the battery is full, or if there is even more energy available, it will export it to the grid. If the house consumption is higher than the photovoltaic output, the inverter will first consume the energy from the battery to avoid importing it from the grid, which you would have to pay for. And it will do it until the battery reaches the set depth of discharge, after which it will switch to the grid. Now, the depth of discharge I can play with. So what I do is I set it to a higher value if there will be a nice and sunny day in the next day, because then the sun will contribute to the consumption, so I don't need that much battery. If the next day is not gonna be so sunny, I leave more in the battery. For the irradiation forecast, I use the forecast.solar integration that is configured exactly for my GSM coordinates and the orientation of my photovoltaic panels. And for the thresholds, I created helpers that I can tweak from the energy management dashboard. So this is what the automation uses. So let's see. The automation is called Set Depth of Discharge Overnight. Again, it's rather simple. It is triggered when there is a sunset, so when the sun goes below horizon. And as well, when I change certain parameters, I want to recalculate and refresh the values. So there's the general condition again. And what I do is I set the value depth of discharge on the grid, which is the entity defined by the GoodWe inverter integration. And I set it either to the value of input number EMS discharge bad day or a good day. So these are the two values I have set up on the dashboard. In general, when there is going to be a bad day, I will have a lower maximum discharge, and if it's going to be good day, I'm going to have a higher discharge. I'll discharge it more because I will be expecting there's going to be a sunny day. How do I decide it's a bad day? Again, there is a variable which is looking at the sensor energy production tomorrow in front. And if the value is lower than the threshold, then it's gonna be a bad day. So I guess this one is pretty straightforward. So we're almost there, but before I get to the last one about the car charging, let me show you one more. When I spoke to the contractor installing the plant, they suggested that it is good to let the battery fully charge at least once a week. That will be mostly needed in the winter, hopefully. The reason being, the full battery capacity is calibrated this way, and they said I shouldn't worry too much about the minimum and maximum battery charge. This is managed by the battery management system. So this is what the automation does. So let's look at it. This automation does two things in one. First is when the battery state of charge is above 99%, so when it's 100% essentially, it'll trigger a fully charged trigger, which is going to set a timestamp when the battery was fully charged. So let's look at that. When it's triggered by the fully charged, it will set daytime of the input daytime last time battery fully charged. So this is a helper I have created, and it'll set it to today's date. So I have a template here. It's actually doing it now, taking timestamp of it and formatting it to year, month, and day. So this is creating a timestamp when the battery was last time fully charged. The other thing what it does is if the battery was in the eco charge mode, then what it's going to do is it will set it to a general mode. So it'll take it out of the eco charge mode. We're using the eco charge mode to charge the battery from the grid. So when it's fully charged, it will switch it back to general in general. So that's the first trigger. And the second trigger is 4 hours before the sunset. And what it's checking is if the battery was fully charged more than a week ago, so more than 7 days ago. And the way it does is it's using this template, so it's doing it as a now, as a timestamp, and then it's taking this input date time, last time battery fully charged, again converting the timestamp. It's converting it from seconds to days, and it's checking whether it's more than 7 days. And what it's doing, it's setting the eco mode power to 75%, and it's setting the operation mode to the eco charge. And that's all there is. Finally, the fifth one. That one controls the car charging. My main goal was to charge the car from the solar power. But when I thought about that, I figured if I would hardwire the charger to the PV output, if I would arrive home in the evening with an empty battery and I'll be leaving in the morning, the battery will still be empty. That won't be good. Or if there is gonna be no sun for the whole week, so maybe I just need to leave it charging from the sun during the day and I need to charge it overnight. But then I might not need to charge it all the way to 100%. And maybe the next day is gonna be sunny and the car might be in the garage all day. So I figured I probably need to work with different modes of operations. Yes, it's complicated, but I and my wife, we committed to accept this complexity to minimize the environmental footprint. So if the car is home during a sunny day, we will charge it from the available solar power. I call it available mode. And we use it mainly from Friday evening till Sunday evening. If I quickly need to charge the car, I can switch it to the full power mode. These two are kind of extreme. But then there is one more mode that is probably smartest from them all. We call it scheduled, and what it does is during the day it will charge the car from the solar panels the same way as available. But then, after the sunset, it will make sure the car is charged at least to a certain level till the morning. Not to 100%, but to a level for the day's commute. But I didn't end there. It will charge it to a different level based on the next day forecast. Because if it's a sunny day, it might still add some 10-15% before we leave. So I will charge it to a lower level overnight. Also, I added one more mode, off mode, that I can control manually remotely, like stop the car charging even during a sunny day for some reason. Now, for controlling the charging current, this could be done in different ways, and really conceptually it's not important how you do that. Ideally, if I had a smart wall box, I could control that. But since I show you my actual setup, I currently do not have one. But I have a Skoda car, and there is an API from Skoda Connect available in the Home Assistant. It's basically a version of Volkswagen WeConnect. And it allows to set the maximum charging current, and it also tells me where the car is, whether it's at home or not. So I do it that way. The downside is that I control the car directly, and I need to make sure that I only do that when the car is at home and connected to the charger. I don't want to limit the charging of my car based on the photovoltaic output at home when the car is charging somewhere else, right? So this is a little bit more complicated than if I just control the wall box, but this is what I have. So let me take it piece by piece. So first, the triggers. It's triggered by a lot of things, but essentially it's triggered by time pattern. So every 5 minutes is triggered. During the day, this is used to adjust the charging current to the changing photovoltaic production, and during the night, when the charging reaches the threshold, it will turn off the charging. So this is the regular checking. Then it's triggered when the charging mode changes between fast, available, scheduled, and off, and I'll get to those a little bit later. It's also triggered when the car leaves the home or comes back to home, or the garage door is opened. So this is another trigger or set of triggers. It's also triggered in a sunset, because then it's changing charging mode for the scheduled one. I'm making sure that overnight I want to make sure that I charge it to a minimum level. And then it's triggered when I change one of the parameters. So it updates the behavior based on the new parameters. Then there is the master switch, and then there are those actions. I will start from the bottom. I will skip the variable, and I will skip those 5 actions. Choose action, which is switching different modes. I'll get to that a bit later. And I'll first look at those last 3 actions that actually describe how the whole charging automation works. So this block is when the charging mode is set to available or scheduled, and it's during the day, so the sun is above the horizon, and the car is at home and the charging cable is connected. So if all of those conditions are met, then what it does is it will set the maximum charging current, so they'll call the API set charger maximum current to this variable that I have calculated in the variable above. And it will only do that if the charging current is more than 2 amperes and if the battery level is less than 0. Now, I do this through a script, and all this script does is it's sort of limiting the number of API calls to the car, because if I every 5 minutes update the current of the car, after a couple of iterations, the API will tell me I have reached the maximum allowed number of API calls, and it'll stop communicating. So what it does is it's communicating the new value with the old one, and if it doesn't change, it just doesn't call the API. So to the calculation of the variable, so there is a variable which basically says it will take the photovoltaic power, and I take roughly half of that. Reason being is we use 3 phases current. Inverter is asynchronous, meaning that theoretically I could take the whole photovoltaic power and feed it to one phase, one of the 3. But in practice, I have learned that about half of the PV power is a reasonable amount. If I try to pull more than that, then it will actually get some help from the battery or from the grid. Then I'm looking at the house consumption. So I'm looking at the average house consumption, and I'm taking half of it. And why I'm taking half, again, it's related to the thing above. So if I only use half of the power for the car, I can very easily use some of the remaining power for the house consumption. And then it's taking the current CityGo charging power, because that one is included in the house consumption, so I'm actually need to take it from there. And then I calculate the difference, which is the photovoltaic minus the house plus the CityGo. And from there, I calculate the charging current, which is gonna be the difference divided by 230 volts, which is the voltage we have here. And I limit it by 0 at the bottom and 11 amperes on the top. So that was that. So this was the available and current during the day. Then during the night, what it does is, if the CityGo is in the charging mode scheduled, so not the available, and if the sun is below horizon, so it's during the night, and the car is at home and it's connected, then if the battery is below the threshold. And what this threshold does is I can say that I'd like to have the car in the morning charged to a minimum level of, let's say, 70%. So it's checking whether the car is less than this 70%, let's say. If it is, it'll keep charging. If it's not, it will stop charging. And then I will set the max charging current to 32 amperes, which is the maximum that the charger allows. Then next, if it's in available and it's during the night, it will turn off the charging, because in available I don't want to charge it during the night. So this is how the available and scheduled modes work. And then look at this main switch, which is covering the off, fast and switching between the modes. So the first option is when I selected the mode into the off position, it'll turn off the charging. So it's rather simple. The other option is when the car left home. What it will do is it will set the charging mode to fast, because if the car is not home, I don't want to limit the charging power. I want to make sure the car charges at a full power. Remember, here I'm talking to the car through the API, so I could theoretically limit the charging power even if the car is somewhere on the public charging station. I don't want to do that. So this is why this is important. And I'm turning off the charging because I don't need it if the car isn't home. Then, when the car returned home, I forced the refresh of the data from the car just to make sure I have the latest battery status. This is a service call through the API to the car. And then I will set the charging mode. Now you know what they are. And I will set it either to available or scheduled. On Friday or on Saturday, I will set it to available. Reason being that I assume that I will need the car on Monday morning, unless I say something else. So I don't need to necessarily charge it during the night from Friday to Saturday and from Saturday to Sunday, but I need to make sure it's charged to the minimum level between Sunday and Monday or during the week. So this is what happens when the car comes home. Now, when it's triggered through the fast charging mode, what it does, it will essentially set the charging to the 32 amperes, which is the maximum, and it'll turn on the charging. So this is rather easy. Then I have a condition that happens on a sunset or when any of the parameters change. And what it's going to do is it's going to set the minimum charging level for the next day. So this is happening here. I'm looking at the energy production for the next day, and if it's below a certain threshold, I say it's a bad day. And then what I do is I will set the minimal charging level for the car. So this is the threshold where I will stop charging the car, either to the value of the input number charging for the bad day or charging for the good day, depending on this variable. So I have those two values. Then I have a condition here that if the charging is not fast, it will continue, otherwise it will end in here. And what it does, it's changing the mode. So if I had this car over the weekend at home and it was set for available, then on Saturday night it will change it back to scheduled, so it will charge over the night till the morning. So that's all this does. There's a lot of different actions. If you'd like to look at the different traces, this is how the whole automation looks like. Quite a lot of branches, lots of things going on. I've included the link in the description, so you can look at that and you can check the details in there. And if you have any questions, you can always come back in the comments or in the Discord channel. So now that we understand the charging modes, I can get back to the first automation and explain the logic for setting up the backup mode for the inverter. And what it does is it'll prevent use of the battery for the house consumption. I use that to prevent the car from being charged from the house battery. Reason being, the car battery is much larger than the battery in the house. So it would just deplete the battery in the house without having any significant impact to the car. And also it would cycle the battery unnecessarily. Well, I set it to backup if the CityGo is charging. And at the same time, if the CityGo is home, because if I charge it somewhere else than home, then I don't care, essentially. And at the same time, if the charging mode is fast or scheduled. These are variables I define in here. So fast is basically means that the selected charging mode is fast. And at the same time, if the photovoltaic power is less than 4 kilowatt. If it's scheduled, it means that there is an automation that is adjusting the charging current of the car during the day. But during the night, the car can still charge if the battery level of the car is below the threshold. So if the charging mode is set to scheduled and the car is still charging during the night, I'd like to set the inverter mode to backup to make sure that the battery is not used to charge the car. I'd like to avoid that. So that's it. Later this year, we'll be getting rid of our second car. It's a diesel car and we'll be replacing it also with an electric car. So then we'll be fully in. We'll be charging 2 electric cars in parallel. It'll be really interesting managing which one is going to be charging. But for now, this is it. Let me know in the comments if you like that. If you did, just hit the like button, subscribe, you know, the usual. Or if you figured something that I missed, let me know in the comments or join the discussion on my Discord server. And I'll see you in the next one. Bye.